For the chain brake P6-26, we're going to be using the polygon tool to generate our outside shape. I have some cuts to make through. When we went through this on the lab demo, noticed that there were some missing dimension on this U shape, and then some things that weren't quite clear. So looking at the print, our section view, AA is looking in this direction at the middle of the cut, and then section BB is looking towards this face in the direction to the left. So we're going to use that information. This is in inches. I looked at this thinking we were still in metric, and wow, 1.44 millimeters. This thing's going to be pretty small. So when we do the polygon, the 0.79 inches across the points is going to give us a circumscribed circle for our base. If we use the inscribed circle, we can still dimension to those points. It's just a matter of which one's going to be more convenient. And then where the pinning gauges for the handle, a 0.313 by an 1/8 inch deep, even that pressed in without a weld or some type of mechanical fit is probably not going to stay in there. So we're probably not going to put that much torque on this, but based on what this is doing, let's get back down here to the face, we're holding on to this. I'd almost say we need a smaller pin with more engagement. The other thing I noticed was the 5/16 18 UNC-1B. The 1B is our loosest tolerance. So if this is used in a dirty, greasy, the threads get banged around, then the intent is that this will still work. Problem is that when we manufacture this part, I'm either going to have to order an oversized tap that will increase the pitch diameter for that, or a standard tap, and then look at when we do the turning that we will probably make this on a lathe, and the single point turning as it goes across this face, we can control that diameter more on the shaft. So that's where, if you hear the terms hole basis and shaft basis for the tolerances, we're really deciding which one we have the most control over, which one's going to be pretty much set, and we're going to have to work around. So if the screw was a purchase part and we're putting in there, that would be we did kind of define the tolerances based on the shaft or the external thread, and in this case, making both parts, we would probably be looking at the tolerance on the hole basis. So let's fly that out of the way. We'll get an inch part going. And I'll check real quick: inch, pounds, seconds. Front plane, open up a sketch. If we go into the sketch tools, we'll pick up the polygon. We'll do this both ways. So inscribed circle, get that close. And if we go to the select, I'll pick one of those faces, and in this case make it horizontal. And looking over to the left, that did apply. And so in this case, I would go point to point and apply the 0.79. And that's going to be fine. There's no issues. A lot of times I don't even really pay attention to the inscribed circumscribed. So if for some reason though we want the circumscribed, we'll change that radio box, make the selection. We're doing basically the same thing, and now the construction circle is on the outside. So same technique, pick one, make it horizontal. The only real advantage here is that we can pick that construction circle, make it the 0.79, and because it's touching on each of the points, that becomes 0.79 across those points or across those tips. The inscribed circle is touching on the flats, and if I pick up a piece of stock out of the rack, I'm probably going to measure across the flats and calculate the points. So if I was doing something that required a clearance, then this would be a little better. So our extrude 1.44 inches, get to decide which way it goes. I'm going to reverse it and go that way. If we look at it from the front, then I will be sketching on the right plane, and this is going to be interior to the part. So L on the keyboard for line, pick up the edge, and we'll start generating our geometry, those little tabs and shapes. I think I got all of them. Look for the inference line. Go ahead and pull this back in so we can look at the dimensions. Alright, so not real fond of the way that this was dimensioned, but 0.29 off of the front. 0.09 is the in-between, 0.06 two places, so 60 thousandths here and here. I look at the 0.19 and everything else is in between, but we look at the extension line to the arrows, 0.19 is actually the in-between, and then the 0.5 off of the edge. So that stack up of tolerances is could be a little bit of an issue later on. And also we start looking at, well, let's go ahead and get into the dimensions. We start looking at, as we're applying these right now, our units are set to 3 decimal places, and most of the time we'll be thinking in 3 decimal places. But in the case of fractional units, when I see a 0.09, I'm thinking 3/32, 0.09, 375, 0.093, for whichever way it goes. And then, we're pretty much a 0.06, a 16th. And the issue is that if you're working in a team environment and you're designing to 2 decimal places and somebody else is designing to 3 decimal places and somebody else is designing to 4 decimal places, there's going to be places or areas in the assembly that are not going to be happy with applying the mates and generating that geometry. So there needs to be consistency that on the fractional units and the inch units, that everybody's on the same page. So select, control, select. I would prefer collinear. Going back through the relations, if I go point, point, and point, those would be horizontal. And if I were to pick the line and a point, that could be coincident, and then I would have 2 coincidences for each of those points. So collinear in this case, and managed to grab the midpoint there. So let's select it again. And it doesn't look like it's going to let me deselect, so we'll just get out somewhere, clear it by clicking, pick, and collinear. And I don't see it over on the left. So let's go ahead and one more time, make sure. Okay, so that one and that one got applied, and that one did get applied, but I didn't see it pop over in the relation. So on our dimension, 0.25 from the bottom, and then those should all move together. And then dimension to the top of the tabs, 0.5. This is in our BB section view. All right, so that did not move together. I could dimension these separate if my design intent is that they will always be the same. Then we'll set those to equal, and in the same selection, make them collinear. All right, so that gives us our geometry. I'm going to rotate over for the extrude so we can see the through wall. Features, extrude cut. And if I go through all, it's going to find the edge of the part. If I go through all both, then it'll go both directions. So I could have done through all, selected direction 2, and done through all both, just turns both directions on. Okay, so that makes the cut. And so the little U shape, looking kind of in that direction of the cut, 100 thousandths, 0.79 across the tips, 0.4, it's a little bit offset, and 100 thousandths off the center doesn't quite line up with the tolerances, so there's a little bit of a shift there. So either that, or when I did it in the demo, the thread location is a little bit off. Either way, it ends up being 5 thousandths because of that rounding error. So would expect that the 0.79, if it was 0.8, then we would have that center. There wouldn't be really an issue on those numbers. So on our U shape, go in. I'll use the S key this time. And I like to draw the rectangle. We'll go ahead and dimension, well, let's go ahead and select the midpoint. So right click on the line, select midpoint, control select the edge, and we'll make midpoint to midpoint. If I go back into the S key, we are in the tangent arc, so I can, and it went the wrong way, so I'm just going to drag back to the beginning and keep dragging back until it gives me the desired result. We'll switch that to a construction line so I don't have to delete it or do anything with it. So, yeah, the habit on the midpoint to midpoint. So decide I'll go ahead and remove the midpoint relation. We still need to be coincident or collinear, so if I do coincident, I'll pick one of the points and the edge and make it coincident. That'll let it move back and forth. Based on our drawing then, from the tip to the center. Oh, and it got the edge because I have the alignment, so let's escape. And make sure I'm grabbing the point so that I can get the 0.4. And being within 5 thousandths, this is really just splitting the 395 number, so we'll see what we get. All right, so our missing dimension. Since we're in fractional, I'm going to go with 0.31, and this is something that we'll need to go back and review when we get to the assembly. So features, extrude cut, and we'll have it go up to that next. So notice through all finds its way to the end of the part. Up to next will terminate at the next face. And then while we're in this orientation, I'll open up the next sketch. This is going to be a little bit harder to see, so I'm going to go to Hidden Lines Visible. And let's see if we fly this back in. So really I'd like to have a dimension either to that tangency point, but the 0.25 to the center of the thread. Then we have radius of 0.19, so 0.38 for the diameter. And it is ½ inch, well, showing that it's even with that edge, so I couldn't find that top edge. But if I'm going to stay with the 0.4 stack up of tolerances off of the dimensioning, then we don't want to be center. We want to pick up that geometry. So one more quick check that is yeah, that's showing up slightly off of center line as well. So I'm gonna always argue for symmetry. And we're gonna see here in a second if I am looking at this in the right direction. So we do want to pay attention to that orientation. So if I go to the 0.4, that's centered within the box, or within the slot. And we want the 0.38 for the diameter, which is going to be a little easier than closing off the arc. And I can always right click and say display as radius. If you're in an earlier version, that right click was added, well, not too long ago. I'd have to check. But if we go click on the dimension, go to the liters tab, and then pick on the radius, it has the same effect. All right, so based on where we're at, and we go in and do the extruded cut, then up to next, should stop there. Not sure why it's showing it going all the way out, so let's double check. I'd have to see what it gets, but if we did an up to vertex, we could pick a corner. So yeah, it's not updating on the preview. And then up to surface would stop there. So let's do an up to surface. Switch back to solid, so it with the shaded with edges, it's a little bit clearer, and we'll see what we get. All right, so when we do the threads, I want to go from this side, and the cosmetic threads are going to be primary in our hole wizard. If we decide we want to do thread features, we'll do those later. So straight tap, 5/16, 18. I'm going to bypass the class of thread here and address it later. But tap drill size, all those look good. And position, now I reversed. Oh, I hit the right mouse button again. So since I'm reversed and looking at the part from this side, so there's the 395. We'll go to the 0.4. So I'm building the case that when we have this kind of symmetry, and even though the stack up is showing as only going to come down to the 0.005 of an inch, that you know, I really think that putting this on center is preferable than having that slight offset. Also, less chance that in the machining process one of these is going to get reversed as it turns around, does the various operations, and end up having the shifts alternate back and forth. So all right, and then that does bring up an interesting manufacturing process with this being 3/8 of an inch. That's going to be fairly difficult to machine when I really stop and look at it. So let's see, just going to double check the number real quick, 0.25, 0.4 off of that edge. We have the geometry. So if this is a casting, we do an aluminum die cast or metal, then that we'll probably be able to clean up, and this would stay a rough surface. Yeah, I just kind of thought about that it would be an interesting issue. So, all right, so looking at it from the side, if we go back to the hidden lines visible, we have the point along this edge of the hex. The bottom, oh, I turned it around, so let's go this way. There we go. So the bottom of the slot, the bottom of the other two slots, the minor diameters, and then the major diameters of the thread for the cosmetic threads. So that'll get us our shape for the hex. And when we get into the assembly, we'll resolve some of these, and we'll probably end up going back and putting all that geometry on center so it ties together. But for now, we will make sure that we're in the assignment. I had my demo version, so this is going to be the chain hex this time. So, and save it.